In this video, we'll be going over 2D kinematics, kinematics equations, and example problem 1. So to begin, I want to talk about the relationship between velocity, acceleration, and displacement. So as you can see written down here, the derivative of displacement is velocity, and the derivative of velocity is acceleration, and the integral of acceleration is velocity, and the integral of velocity is displacement. So that's just a relationship that we should know. So take some time to write those down and memorize that. Next, what I want to go over is these equations. So the first one is to get displacement. So to get displacement, it's going to be the initial position plus the initial velocity times time plus 1/2 times the acceleration times time squared. So just remember that equation, it'll come in handy for our example problem. The next equation we're going to know is for velocity. So for velocity at any time, it's initial velocity plus acceleration times time. So those equations will come in handy, and you should definitely write those down. And for all acceleration when we're talking in terms of y, usually acceleration for y is just going to be gravity. So gravity can approximate 9.81, but we'll usually just have that as 10 meters per second squared in the problems that we do. It's easier that way to approximate. Okay, so now we're going to go on to the problem. Here's the problem, example 1. So the problem is, a plane starts at rest on a straight runway. For the first 30 seconds, the plane's acceleration a is given as a function of time by the equation a equals bt squared, where b equals 1/90 meters over seconds to the fourth, and t is in seconds. What is the plane's speed at t equals 30 seconds? So for this for this problem, there's two ways that we can do this. The first being that they give us the equation for the plane's acceleration, so that equals a, so acceleration equals b over t squared. So now if we take the derivative of this to get velocity, the integral of this, we can get velocity. So we'll take the integral of this so we're gonna put this in here, t squared, and we know that's dt, so we know that's 1/90, so we can simplify this to 1/90, take the integral of t squared dt, and that equals, if you can see here, I'll move it into the shade, I'll move it down here, that equals 1/90 times, we can simplify the integral, so the integral of t squared dt is times 1/3 t cubed. So now we can use that, and we know what the value of t is. T is 30 seconds, right? So now if we just plug in 30 for t, we'll have 1/90 times 1/3 times 30 cubed. and that will give us, if you do the calculations and all that, that'll give you 100 meters per second. So that's the answer, as we can see